Let's talk about how we can see if an argument is valid using a truth table. So to do that, we have 5 steps, although the 5 steps really aren't that many steps. It's all things we've done before except actually checking, is this argument valid? So the first thing you're going to do, use a letter to represent each simple statement in the argument. Okay? We do that all the time. Anytime we're going to symbolize a statement or symbolize something, we choose a letter for each of the simple statements. Great. Step 2, express the premise and the conclusion symbolically. Just symbolize them. Okay, we talked about how to do that. Put premise 1 on one line, premise 2 on the next line, premise 3 on the next line. Draw your line when you're done listing your premises. 3 dots, conclusion. Fine. Next, write a symbolic conditional statement that has this exact form. Okay, I'm going to take premise 1, put it in parentheses, put an and, take premise 2, put it in parentheses, and I'm going to do this exactly every time I have a premise that's more than a single letter or the negation of a single letter. I'll put it in parentheses to make sure the ands don't get mixed in there. I'm also going to put my list of all my premises inside of brackets, okay, inside of these square guys. So I keep listing my premises with ands in between them until I get to the last one. And then finally, I'm going to draw my if-then arrow and put my conclusion. Okay, so this will be one potentially really big conditional statement. Next up, nice and easy, make the truth table for that statement. And then the way that I know if my statement or if my argument was valid, if my statement from step 3 is a tautology, meaning everything in the last column, everything underneath it is trues, the argument is valid. If the final column has any falses, even one false, then the argument is invalid. All right, let's walk through an example of doing this. So here's an argument. If it is cold, then my car won't start. My car started this morning, therefore it was not cold this morning. So I'm going to let P be, it is cold. I'm going to let Q be, my car will start. Okay, then it was not cold. Great. I've done part 1. Step 1, done. Step 2, express the premises and the conclusion symbolically. First premise, if it is cold, then my car won't start. If P, then not Q. Premise 2, my car started this morning. My car will start. Q. Done with premises, on to the conclusion. It was not cold this morning. Therefore, not cold, not P. All right. I have expressed the premises and the conclusion symbolically. Step 3, write a symbolic conditional statement that has that crazy form. So I want to do, I need my bracket, parenthesis, if P then not Q, and premise 2 is Q. Since it's just a single letter, I don't need parentheses around it. Okay, I've listed all of my premises, so I can put my square bracket to end. Then I need my if-then arrow, and then I need my conclusion. Again, since my conclusion is just a single letter, or the negation of a single letter, I can just write it. There is the statement that I want to move forward with. So there is the symbolized entire argument. That's what I'm going to check to see, is this argument valid? Okay, so step 4, construct the truth table for that statement. So I need this whole thing. If P then not Q, and Q, only if not P. So to get there, I'm going to need a few things. I'm going to work backward here, since if I don't, I'm afraid I'll run out of space. I'm going to need to know the truth value of that statement. If P then not Q and Q. Okay, to do that, I'm going to need to know the truth value of if P then not Q. To do that, I'm going to need to know not Q. And way over there, I need to know not P, P, Q, 2 simple statements. So I need 4 lines, 1, sorry, there's 1, 2, 3, 4. Break apart my statements I want to work with. Okay. Underneath Q, true, false, true, false. Underneath P, true, true, false, false. Not P, opposite of P, false, false, true, true. Not Q, false, true, false, true. If P, then not Q. So I'm going to look if here, then there. So if, whoa, easy IntelliPen. If true, then false is false. If true, then true is true. If false, then false is true. And if false, then true is true. Okay, one column done. Now for the next one, I need to look at that thing I just did and Q. So so false and true is false. True and false is false. True and true is true. And true and false is false. Okay, so I have that column. Now I need if the column I just did, then not P. So if this, then that. So if false, then false is true. If false, then false is true. If true, then true is true. And if false, then true is true. There, I made the statement made the truth table for that statement. Now, how do I know if it's right? If the statement from step 3 is a tautology, then the argument is valid. So I look here. Is this a tautology? Well, there's a T, a T, a T, a T. Yes, all of those are trues. So this statement is a tautology. So my argument is valid.